Ready, sir?
Ready, sir.
Start.
Sir, 9:55. No, it'll start.
Start, sir. No, but 5 minutes is there, sir. But it's online connecting class is there.
Okay, madam. Okay, sir. Thank you. Dear student, welcome to the online webinar classes for intermediate student, which is conducted by Tri Society. So this is the Mahipal Reddy, PGT Maths, Peddapur camp. So first of all, I would like to say thanks to our Honorable Secretary Sir, Ramana Kumar Sir, Deputy Secretary Sir, and all the principals of Tsrs&Jc, and my dear colleagues. Thank you for giving this opportunity. So, dear student, you're already completed in the MATHS-2B the 5 chapters: circles, system of circles, parabola, ellipse, and hyperbola. Now, the next chapter, the continuous, is the integration. In this chapter, integration, in the IB examination, board examination, the marks weightage is there are 2 marks questions too, and 7 mark questions too. Total 18 marks weightage in the IPE examination. So in this chapter, we're going to learn. So first topic is definition of integration. So next, second one is the standard forms and properties of integrals. Standard form means we are going to learn some formulas and properties of integrals. And the second one is integration by substitution method, 6.2. In that 6.2, the A topic is integration of algebraic and trigonometric functions by method of substitution, and integration by parts, integration partial fraction method, and last one is reduction formula. But in this COVID situation, the last 3 topics means integration by parts, integration by partial fraction method, and reduction formula are deleted for this academic year. So these 3 topics are removed, especially for this academic year: integration by parts, integration partial fraction method, and reduction formula. So means we are going to learn only for this academic year definition of integration and a standard form and the properties of integrals, integration of algebraic method, algebraic trigonometric function by method of substitution. Only these 4 topics we are going to learn. So especially today is the day 1. Today we are going to learn definition of integration and a standard form of integration, properties of integrals, and some related examples, and exercise 6A, 1 first bit. So recall what we learned in the intermediate first year. In the 1B, you learned the differentiation. So I am going to recall some what we learned in the 1B. So you learned already the derivation of x power n, d of x power n by dx, it is equals to n into x power n minus 1. This is already you learned in the intermediate first year. Derivative of x power n, it is equals to n into x power n minus 1. And a derivative of e power x exponential function. Derivative of exponential function is e power x. Third one is derivative of a power x with respect to the x variable. It is equals to a power x into log a. And a derivative of logarithmic function, derivative of log x with respect to the x variable, it is equals to 1 by x. Derivative of trigonometric functions. Now we are going to learn the trigonometric functions. Derivative of sine x. We know that this is the cos x. And the derivative of cos x, it is equals to minus sine x. Derivative of tan x, it is equals to sec square x. Derivative of tan x equals to sec square x. Derivative of cot x, it is equals to minus cosec square x. Derivative of sec x, it is equals to sec x into tan x. So derivative of cosec x, it is equals to minus cosec x into cot x. So again, derivative of x power n into x power n minus 1, derivative of e power x is the e power x, derivative of a power x is a power x into log a, derivative of logarithm function is equals to 1 by x, and remaining trigonometric functions. Differentiation of sin x is the cos x, difference of cos x is the minus sin x, derivative of sin x is the sec square x, and the derivative of cot x is the minus cosec square x, derivative of sec x is the sec x into tan x, derivative of cosec x, last one, derivative of cosec x equals to minus cosec x into cot x. So now we are going to learn what is the definition of integration. So children, this already you learned this differentiation in the first year. So what is the process to get the n into x power n minus 1? What we have to do to get the x power n? Or what is the process to get 1 by x, to do 1 by x to get the log x? That is known as the integration. That means integration is nothing but is the inverse process of differentiation. So children, you already learned the differentiation in the first in the previous year. So here we're going to learn the integration. Integration is nothing but what you done in the differentiation. The reverse process is called, or inverse process is called integration. So, so what is the definition of integration? Let small f is a function from e to r, capital E to r is the real number, E is the domain here, and capital F is also a function on the same domain E. That means both the functions, small f and capital F, both are the functions on the same domain E, such that f dash of x, that means derivative of capital F dash of x is the small f of x for all x belongs to E. Capital, the derivative of capital function is the small function. Then we called f an antiderivative. Antiderivative is nothing but inverse process of derivative. It is called antiderivative of f, or primitive of f, or integration of f. So we know that here f, small f of x is called derivative of capital F of x, and capital F of x is called antiderivative or primitive or integration of f. So it is denoted by, so the symbol is called here integration. Integration f of x dx equals to capital F of x plus c. So this is symbol. This symbol is called integration symbol, and c c is called constant of integration. Constant of integration, and integration f of x dx is called integrand. So this is total is called integrand. Okay, and x is called variable of integration. Okay, so once again, integration is the simple inverse process of differentiation. And what is actually in the words? The definition is later. Small f is e to r is a function, and a capital F is also function in the same domain E, such that capital F dash of x equals to f of x. Then f is called antiderivative or primitive of f or integration of f. It is denoted by integration f of x dx. It is equals to capital F of x plus c, where c is called constant of integration, and integration f of x dx is called integrand, and x is called is a variable of integrand. Now we are going to learn some standard forms. So by using the standard forms, so this is already the derivative parts you are already learned in the last year. Derivative of x power n plus 1 by n plus 1 will get x power n. So the derivative of x power n plus 1 is the n plus 1 into x power n. So n plus 1 will be get cancelled. So the answer is the x power n. The derivative of x power n plus 1 by n plus 1 equals to x power n. Children, we know that integration is the inverse process. So inverse process is nothing but what we the integration of x power n. Integration of x power n, it is equals to x power n plus 1 by n plus 1 plus c. Children, this is a very important formula entire this chapter. So integration of x power n with the variable x with respect to the variable x equals to x power n plus 1 by n plus 1 plus c. Second one, the derivative of log x. The derivative of log x is the 1 by x. So it implies integration of 1 by x dx equals to log x plus c. Integration of 1 by x equals to log x plus c. And the third one is derivative of a power x by log a. The derivative of a power x is the a power x into log a. The log a, the numerator log a, denominator log a will be get cancelled. We will get only the a power x. That implies integration of a power x dx equals to a power x by log a plus c. And next one is the derivative of e power x. Differentiation of exponential function is the same exponential function. So that's why it is implies integration of e power x dx equals to e power x plus c. And the fifth now trigonometric functions. Derivative of sine x, it is equals to cos x. The derivative of sine function is the cosine function. That's why the integration of cos x with respect to the x variable, it is equals to sin x plus c. So children, again, one more. These are all are the important formulas. The integration of 1 by x is the log x. Integration of a power x is the a power x by log a. Integration of e power x equals to e power x. Integration of cos x equals to sin x. Next, some more formulas, standard forms. Now the sixth one is derivative of cos x. We learned the previous one. Fifth one is the derivative of sin x is the cos x. That's why the integration of cos x is the sin x. But here, the derivative of cos x is the negative of sin x minus sin x. That's why integration of sin x, it is equals to minus cos x plus c. Seventh one, derivative of tan x, it is equals to sec square x. It is implies integration of sec square x, it is equals to tan x plus c. Eighth one, derivative of cot x, derivative of cot x equals to minus cosec square x. Derivative of cot x equals to minus cosec square x. It is implies integration of cosec square x equals to minus cot x plus c. Next, ninth one, derivative of sec x, it is equals to sec x into tan x. It is implies integration of sec x into tan x, it is equals to sec x plus c. Next, 10th one, derivative of cosec x, it is equals to minus cosec x into cot x. It is implies integration of cosec x into cot x, it is equals to minus cosec x plus c. So in the fifth one, integration of cos x is the sin x. Next, sixth one, integration of sin x is the minus cos x. Integration of sec square x, it is equals to cot x plus c. Integration of cosec square x, it is equals to minus cot x plus c. Integration of sec x into tan x is the sec x, and integration of cosec x into cot x, it is equals to minus cosec x plus c. Children, this is simply you already learned in the first year the differentiation. From that, we are getting the integration. Next, some more formulas, some more standard forms. Now, the 11th one is inverse trigonometric functions now. The derivative of sine inverse of x. The derivative of sine inverse of x equals to 1 by under root of 1 minus x square. The derivative of sine inverse of x is 1 by under root of 1 minus x square. Similarly, same derivative of cos inverse of x, cosine inverse function. Just the sign is different here. For the sine inverse and cos inverse, sine inverse is the 1 by under root of 1 minus x square, and the derivative of cos inverse x, it is equals to minus 1 by under root of 1 minus x square. This implies integration of 1 by under root of 1 minus x square. Children, listen carefully. Integration of 1 by under root of 1 minus x square. It is the sine inverse of x plus c or minus cos inverse of x plus c. So simple, just only the our convenient we can write the values either sine inverse of x or minus cos inverse of x. So when the question is, it is given under root integration of 1 by under root of 1 minus x square, it is equals to sine inverse of x or minus cos inverse of x. Next, 12th one, this is also same inverse trigonometric functions. Derivative of tan inverse of x. derivative of tan inverse of x equals to 1 by 1 plus x square. Tan inverse derivative of differentiation of tan inverse of x, it is equals to 1 by 1 plus x square. Same, the derivative of cot inverse of x. The derivative of cot inverse of x equals to minus 1 by 1 plus x square. Here also the same, only the sign is different. Tan inverse of x is the plus 1 by 1 plus x square. The derivative of cot inverse of x is minus 1 by 1 plus x square. It is implies integration of 1 by 1 plus x square equals to tan inverse of x or minus cot inverse of x. So integration of 1 by 1 plus x square dx equals to tan inverse of x or minus cot inverse of x plus c. Next one more 13th one is, so again in the 11th one sine inverse and cos inverse functions, 12th one tan inverse and cot inverse functions, and 13th one is sec inverse and cosec inverse 6. Derivative of sec inverse of x, it is equals to 1 by modulus of x into under root of x square minus 1. The derivative of sec inverse of x equals to 1 by modulus of x into under root of x square minus 1. Derivative of cosec inverse of x, derivative of cosec inverse of x equals to minus 1 by mod x into under root of x square minus 1. Here also the only the sign is different here. Sec inverse is plus 1 and cosec inverse is minus 1. So from this, it is implies integration of 1 by mod x into under root of x square minus 1. It is equals to sec inverse of minus 6 or cosec inverse of minus 6. So simply, so when the question is integration of 1 by under root of 1 minus x squared is the sine inverse of x or minus cos inverse of x. Integration of 1 by 1 plus x squared is the tan inverse of x or minus cot inverse of x. Integration of 1 by under mod x under root of x squared minus 1, it is equals to sec inverse of x minus cosec inverse of x. Next, so you learned here exponential functions, logarithm functions, and trigonometric functions, inverse trigonometric function. Now we are going to learn hyperbolic functions. So sine hyperbolic function, the derivative of sine hx, sine hyperbolic function differentiation is the cos hyperbolic function. That's why that means derivative of sine x, it is equals to derivative of sine hx, it is equals to cos hx. It is implies integration of cos hx, it is equals to sine hx plus c. The derivative integration of cos hx equals to sine hx. 15th one, derivative of cos hx, it is equals to sine hx. That implies integration of sine hx, it is equals to cos hx plus c. 16th one, the derivative of tan hx, tan hyperbolic function is the sec h square x. The derivative differentiation of tan hx equals to sec h square x. It is implies integration of sec h square x dx equals to tan hx plus c. Next 17th one, the derivative of cot hx, it is equals to minus cosec h square x. So it is implies integration of cosec h square x dx equals to minus cot hx plus c. So integration of cos hyperbolic function is sine hyperbolic function. That is the integration of cos hx equals to sine hx, and integration of sine hx is the cos hx, and integration of sec h square x equals to tan hx, and integration of cosec h square x, it is equals to minus cot hx plus c. Some more standard forms. Now 18th one, derivative of sec hx equals to minus sec hx into tan hx. It is implies integration sec hx into tan hx, it is equals to minus sec hx plus c. Next 19th one, last hyperbolic function, derivative of cosec hx equals to minus cosec hx into cot hx. So it is implies integration of cosec hx into cot hx, it is equals to minus cosec hx plus c. So hyperbolic functions also completed. Next, what is inverse hyperbolic functions. So derivative of sine h inverse x, it is equals to 1 by under root of 1 plus x square. So sine inverse function is just 1 by under root of 1 minus x square, and a hyperbolic function sine h inverse x is equals to 1 by under root of 1 plus x square. That implies integration of 1 by under root of 1 plus x square, it is equals to sine h inverse of x plus c. Or this also we can express into logarithm form. We can write it is equals to, instead of the sine h inverse of x equals to log of x plus under root of x square plus 1 plus c. C is the constant here in the all problems. So children, listen. Integration of 1 by under root of 1 plus x square, it is equals to sine h inverse of x, or log of x plus under root of x square plus 1 plus c. Next to 21, this is also you learned in the intermediate first year. The derivative of cos inverse hyperbolic function, that means cos h inverse of x equals to 1 by under root of x square minus 1. So cos h inverse of x differentiation is 1 by under root of x square minus 1. So from this, we can get integration of 1 by under root of x square minus 1 dx. This equals to cos h inverse of x plus c, or log of x plus under root of x square minus 1 plus c on when the domain is 1 to infinite. So when the domain is, that means x belongs to 1 to positive infinite. So this value is cos h inverse of x, or log of x plus under root of x square minus 1. Or when the domain is minus infinite to 1. When the domain is minus infinite to 1, the integration of 1 by under root of x square minus 1, it is equals to minus cos h inverse of x plus c, or minus log of x plus under root of x square minus 1 plus c. Now the 22nd one. Derivative of tan h inverse of x, it is equals to 1 by 1 minus x square. The derivative of tan h inverse of x equals to 1 by 1 minus x square. It is implies integration of 1 by 1 minus x square dx, it is equals to tan h inverse of x plus c. And last one more, 23rd, derivative of x. Derivative of x with respect to x equals to 1. That implies integration of 1 with respect to the x variable, it equals to x plus c. Integration of 1 dx equals to x plus c. So children, we already learned these all formulas. Look at one more time. The integration of x power n, it is equals to x power n plus 1 by n plus 1. Integration of 1 by x is log x. Integration of a power x is the a power x by log a. Integration of e power x is the e power x. Integration of cos x is the sin x. Integration of sin x is the minus cos x. Integration of sec square x is the tan x. Integration of cosec square x is the minus cot x. Integration of sec x into tan x is the sec x. Integration of cosec x into cot x is the minus cosec x plus c. And the next integration of 1 by under root of 1 minus x square, it is equals to sin inverse of x or cos inverse of x. Integration of 1 by 1 plus x square is the tan inverse of x or minus cot inverse of x. Integration of 1 by mod x into under root of x square minus 1, it is equals to sec inverse of x or minus cosec inverse of x. And a hyperbolic function, integration of cos hx equals to sin hx. Integration of sin hx equals to cos hx. Integration of sec h square x equals to tan hx. Integration of cosec h square x equals to minus cot hx. Integration of sec hx into tan hx equals to minus sec hx. Integration of cosec hx into cot hx, it is equals to minus cosec hx plus c. And a 21 integration of 1 by under root of 1 plus x square, it is equals to sin h inverse of x or log of x plus under root of x square plus 1. Integration of 1 by under root of x square minus 1, when the domain is 1 to infinite, the value is cos h inverse of x or log of x plus under root of x square minus 1. Or when the domain is minus infinite to 1, the value is just the sign is different for this. 1 to infinite is plus cos h inverse of x. When the domain is minus infinite to 1, the value is minus cos h inverse of x or minus log of x plus under root of x square minus 1. 22nd one, integration of 1 by 1 minus x square, it is equals to tan h inverse of x. The 23rd, derivative of x is the 1. That's why the integration of 1 with respect to the x variable is the x, or with respect to the y variable, the last one, the value is the y. So children, these 23 standard forms are important while going to solving the problems. But look at the children, in each and every formula or standard forms, we are using the c, constant c. Why we are using the c? So now I'm going to explain why we are using the value is constant, always the c. Look at the children, already you learned the derivatives. Derivative of x power n plus 1 with respect to the x variable. So it is equals to derivative of x power n is derivative of x power n is n into x power n minus 1. The derivative of 1 is 0. The derivative of x power n is the n into x power n minus 1. And a derivative of constant numerical value, that is the 1, the derivative of 1 is the 0, always 0. So, but we know that integration is the inverse process. So the integration of n into x power n minus 1 with respect to the variable x, it is equals to x power n plus c plus 1. Here the constant is the 1. Similarly, derivative of x power n plus 2, the derivative of x power n is the n into x power n minus 1, and derivative of 2 is 0. So same, integration of n into x power n minus 1 from the second one, we are getting x power n plus 2. Same, one more, derivative of x power n plus 3 with respect to the variable x. So derivative of x power n is n into x power n minus 1, and the derivative of 3 is 0. So that implies integration of n into x power n minus 1, it is equals to x power n plus 3. Student, observe this. From this 3, so n into n into x power n minus 1, first time we are getting the value is x power n plus 1. And in the second, n into x power n minus 1, we are getting the answer is x power n plus 2. And n into integration of n into x power n minus 1, we are getting the x power n plus 3. And so on, we are using the constant values 4, 5. Similarly, I am using the k. K is nothing but k is belongs to R is real number set. So any constant value, derivative of x power n plus k with equals to n into x power n minus 1. So here from here we are getting integration of n into x power n minus 1. It is equals to x power n plus k. So look at from this all, the integration is the same. Integration of n into x power n minus 1. We are getting one time is the x power n plus 1, and one more second time is x power n plus 2, and one more time is x power n plus 3, and one more time is x power n plus k. So the constant values are maybe differ 1, 2, 3 or any. So that's why instead of the k, we are using the value is the c. Till I think understand why we are using the value is the c. So look at here, we are getting first time is the 1, or second time is the 2, or here, these are the examples only, is the 3 or k. Instead of the k, we are using the value is the c. So some properties of integrations. If f comma g are integral functions and k belongs to R, again the k is nothing but real number, then integration of f plus g of x, that means sum of the two functions. Integration of sum of two functions is nothing but integration of f of x dx plus integration of g of x dx plus c. So when the functions, when the addition of the two functions, integration of addition of two functions, nothing but we can write the individual integration of f of x dx plus integration of g of x dx plus c. And the second one is integration of k into f of x dx. K is nothing but real number. That means multiplication of the scalar here. Nothing but k into integration of f of x dx plus c. Third one, differentiation of two functions. Integration of f minus g of x dx equals to integration of f of x dx minus integration of g of x dx plus c. Fourth one, the functions are n functions, f1 plus f2 plus dash dashes fn, where f1, f2 are integral functions. Integration of f1 plus f2 plus dash dashes plus fn of x dx equals to, we can write again the individual integration of f of x dx plus integration of f2 of x dx plus dash 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 plus integration of fn of x dx plus c. These are the four properties of integrations. Now we are going to learn some solved problems. So find 2 into integration of 2 into x power 7 dx. So solution, what is a given question? I am writing the first here. Integration of 2 into x power 7 dx. We have the question is the find integration of 2 into x power 7 dx, and the domain is the or. So what is the given question I am writing here? It is in the form of the k into f of x. So the 2 is the constant here. I'm writing the outside. So 2, I'm writing here 2 into integration of x power 7 dx. Look at this is in the form of the integration of x power n dx, but from the standard form, integration of x power n is nothing but x power n plus 1 by n plus 1 plus c. So where the compare these two, n value is the 7. So the 2 is the same. Now the value of the integration of x power 7 is nothing but x power 7 plus 1 by 7 plus 1 plus c. Same, the n value instead of the n I am substituting is here 7. So integration of x power 7 is the x power 7 plus 1 by 7 plus 1. So it is equals to 2 into x power 7 plus 1. 7 plus 1 is the 8 by 8. 2 into x power 8 by 8 plus c. Nothing but 2 ones are 2 fours are. So this is nothing but x power 8 by 4 plus c. So the given question is therefore integration of 2 into x power 7 dx equals to x power 8 by 4 plus c. So c is any constant here. Second problem, solved example. Find integration of cot square x dx. Find the integration of cot square x dx. Again, the solution, the given question is integration of cot square x dx. But we know that trigonometric identities, third identity, cot square x can be written as cosec square x minus 1. So I'm going to substitute here. So the cot square x is a cosec square minus 6, cosec square x minus 1. So I'm substituting here. Cot square x is the cosec square x minus 1. So again, this is the form of the integration of f of x minus g of x. So I'm writing here integration of individual cosec square x and minus integration of 1 into dx. But we know that integration of cosec square x from the standard forms, integration of cosec square x, it is equals to minus cot x. So cosec square x is the minus cot x. So I'm substituting is here integration of cosec square x, it is a minus cot x, and the integration of 1 with respect to x variable is the x plus c. So that implies integration of cot square x dx, it is equals to minus cot x minus x plus c. So simple, integration of cot square x is the cot square x can be written as cosec square x minus 1. So I'm writing the individual, and integration of cosec square x is the minus cot x, and integration of 1 is the x. So that's why therefore integration of cot square x dx equals to minus cot x minus x plus c. One more third example here. Evaluate integration of x plus 1 by x whole cube. This children, this is important question, 2 marks question, so many times repeated in the IP examination. integration of x plus 1 by x whole cube with respect to the dx, x variable. Solution, what is the given question I am writing is here as it is integration of x plus 1 by x whole cube. Now I am going to expand by using the a plus b whole cube formula. A plus b whole cube formula is a cube plus b cube plus 3a square b plus 3ab square. So a value is the x now here. So a cube nothing but x cube, b cube is nothing but 1 by x cube, 3a square, a is the x here, 3x square into 1 by x, b value 1 by x, plus 3ab square, 3 into x into 1 by x square. So I am again writing the integration is the individual integration of x cube, integration of 1 by x cube, 1 by x cube can be written as the variable is present in the denominator when it is bring to the numerator x power 3, it become x power minus 3. And here x squared by x, 1x cancel, and remaining is 3x. 3 I am writing the outside integration of x. And here 3 I am writing again outside x by x square. So it's nothing but 1 by x. 1x cancel, remaining is 1 by x. So now the result is the integration of x cube dx plus integration of x power minus 3 dx plus 3 into integration of x dx plus 3 into integration of 1 by x dx. So same integration of x power n, the previous problem, x power n, it is equals to x power n plus 1 by n plus 1. So x power 3 plus 1 by 3 plus 1 plus x power minus 3, n value is the minus 3 plus 1 by minus 3 plus 1 plus 3 into x power n value is the 1, 1 plus 1 by 1 plus 1 plus 3 into integration of 1 by x is the log x plus c. X power 4 by 4 plus x power minus 2 by minus 2 plus 3 into x square by 2 plus 3 log x plus c. So it can be written as x power 4 by 4 minus 1 by 2x square plus 3x square by 2 plus 3 log x plus c. So therefore, integration of x plus 1 by x whole cube equals to x power 4 by 4 minus 1 by 2x square plus 3x square by 2 plus 3 log x plus c. So now exercise 6a, evaluate the following integrals. So in that first one is integration of x cube minus 2x square plus 3 and the domain is R. Solution, what is the given question I am writing is there integration of x cube minus 2x square plus 3. Again, I'm writing the individual integration of x cube dx minus 2 into integration of x square plus 3 into 1 into dx. It is in the form of the x power integration of x power n. It is equals to x power n plus 1 by n plus 1. So the first one is integration of x cube, nothing but x power 4 by 4 minus 2 into integration of x square is the x cube by 3 plus 3 into integration of 1 is the x plus c. So x power 4 by 4, it can be written as minus 2x cube by 3 plus 3x plus c. Therefore, integration of x cube minus 3x minus 2x square plus 3 is equals to x power 4 by 4 minus 2x cube by 3 plus 3x plus c. Third problem in the exercise 6a, first bit, find or evaluate integration of cubed root of 2x square. What is the given I'm writing is here integration of cubed root of 2x square. Again, the 2 is the constant. I'm writing the outside cubed root of 2 integration of cubed root of x square dx. So this is the cubed root of x square is the third form. I'm transforming into exponent form. This can be written as x power 2 by 3 dx. So again, it is a form of the integration of x power n. The n value is here 2 by 3. So x power 2 by 3 plus 1 by 2 by 3 plus 1. Integration of x power n is the x power n plus 1 by n plus 1. Here the n value is the 2 by 3. 2 by 3 plus 1 by 2 by 3 plus 1. So 2 by 3 plus 1 is nothing but 5 by 3. That means cube root of 2 into x power 5 by 3 by 5 by 3 equals to cube root of 2 into 3. 5 by 3 is become the 3 by 5 when to come to the numerator. 3 by 5 into x power 5 by 3 plus c. So it implies 3 by 5 cube root of 2 into x power 5 plus c. Therefore, the solution is integration of cube root of 2x square. It is equals to 3 by 5 into cube root of 2 into x power 5 plus c. Fourth one, integration of x square plus 3x minus 1 by 2x. Evaluate or find integration of x square plus 2 plus 3x minus 1 by 2x. Again, solution same. What is the given question here? Integration of x square plus 3x minus 1 by 2x. So I'm writing the denominator is the individual integration of x square by x plus 3 by 2 outside, integration of x by x minus this 1 by 2 outside, 1 by x dx. So x square by x is nothing but x, and x by x is nothing but 1. It is now, it's become 1 by 2 into integration of x dx plus 3 by 2 integration of 1 into dx minus 1 by 2 integration of 1 by x dx. So integration of x is x squared by 2. Integration of 1 is the x. Integration of 1 by x is the log x. So this implies 1 by 2 into x squared by 2 plus 3 by 2 into x minus 1 by 2 into log x plus c. It become x squared by 4 plus 3x by 2 minus log x by 2 plus c. So this is the answer. What is the given question here? Integration of x squared plus 3x minus 1 by 2x. It is equals to x squared by 4 plus 3x by 2 minus log x by 2 plus c. Last problem for today class. Again, evaluate integration of e power x minus 1 by x plus 2 into 2 by under root of x square minus 1 dx. What is the given question is here? Integration of e power x minus 1 by x plus 2 by under root of x square minus 1. So again, the integration, I'm writing the individual integration of e power x dx minus integration of 1 by x dx plus 2 into integration of 1 by under root of x square minus 1 dx. But we know that integration of 1 by under root of x square minus 1 dx equals to cos h inverse of x plus c, or it also can be written as log of x plus under root of x square minus 1. But I'm substituting is here. I'm substituting for this value cos h inverse of x. So integration of e power x, exponential function, differentiation or integration is the same function e power x, and integration of 1 by x is the log x plus 2 into integration of 1 by under root of x square minus 1 is the cos h inverse of x plus c. So the solution of the given question is e power x minus log x plus 2 cos h inverse of x plus c. Children, I have to do the some homeworks. This is the assignment. Today assignment is evaluate the following integrals. So first question is integration of 2x into root x dx, and the second one is integration of 1 minus root x by x dx. Third one is integration of x plus 4 by 1 plus x square dx. And the fourth one is integration of 1 by 1 minus x square plus 1 by 1 plus x square dx.
Sir,
Sir, I'm hello. I'm going to close, sir. Just few minutes. Integration of 1 by under root of 1 minus x square plus integration of 1 by 1 plus x square dx. And sixth one is integration of 1 plus 2 by x minus 3 by x square dx. Children, complete this homework and post your concerned subject teacher. Thank you.